the potential difference between any 2 points in a circuit is a measure of the electrical energy transferred by each coulomb of charge as it moves from one point to another.
I see. Then, teacher, where does the source come into the picture?
Good question. The voltage capacity of the source would be analogous to the height of the aeroplane you're jumping off from.
I get it. The greater the voltage, the more electrical energy it can dissipate, similar to how height and GPE are related.
Wonderful. So, Anushka, let me give you a challenge. Based on the definition, can you define 1 volt where the volt is the unit of potential difference?
Sure. If the potential difference between 2 points is 1 volt, then 1 coulomb of charge moving from one point to another would transfer 1 joule of electrical energy to any other forms of energy, right?
Yes. Splendidly done.
Thanks. Teacher, in one of our lessons, we discussed the change in the potential energy in terms of work done. Can we also apply the same logic to electrical energy as well?
Yep, that's right. Can you recall what you've learned back then?
Of course. Basically, we learned that the work done on the object to transport it from lower potential to higher potential would be equal to the potential difference.
Couldn't have said it better myself. That means we can define potential difference in terms of work done on the charge to move it from lower potential to higher potential. Also, note that potential difference is denoted by a capital V.
Oh wow! Even though I had learned about this topic before, I never made this connection. Thank you, teacher.
That's what I'm here for. Do you have any questions?
No, teacher. I understand it perfectly.
Great. In that case, if I say that the potential difference between 2 points of this wire is 1.5 volts, what does it mean? Let's say that point A is at a higher potential.
A potential difference of 1.5 volts implies that we need to do 1.5 joules of work in order to move 1 coulomb of charge from point B to point A.
Wonderful. Now I know, you know what I know. Be careful about the sign convention though.
Sign?
Yes, in reality, the negative terminal has higher potential energy, but since the conventional current flows from positive to negative, we consider the positive terminal to be at a higher electric potential than negative.
Oh, so it is the exact opposite.
Finding this helpful? We have additional learning resources to offer. For Cambridge IGCSE and AS A-level subjects,
if we follow the comparison between mechanical and electrical energy, electrical power must be similar to mechanical power, right?
Indeed. You brought up a good point. Can you tell me what you know of power so far?
Well, I know that the power is the rate of doing work, that is, energy per unit time.
Correct. That is the same whether it be mechanical or electrical. So, what is the work done in the latter case?
From the definition of potential difference, the work done would be the voltage times charge.
Good. So, if we divide this by time, we obtain the formula for power. P equals V times Q divided by T. Notice something interesting about this equation?
Not really.
Let me help you.
Oh wow! Q over T is simply current, isn't it? That means P equals V times I. I have used this formula before.
You've got it. By the way, There are two more forms of power that you should be aware of.
2 more? I would like to see them.
Sure. These forms are obtained by modifying the right-hand side of the equation. More specifically, we want to bring resistance into the mix.
Oh, yeah. I felt that something has been missing here. So, teacher, how are we supposed to do that?
By utilizing the relation potential difference equals current times resistance, or V equals I times R.
Isn't that a result of Ohm's law?
It is. But we'll talk about this law in detail in the next lesson. For now, let's just use the equation. Sounds good?
Yep. So, what are we modifying first?
First, let's replace V. Since V equals I times R, P becomes I times R, or P equals I squared R.
Cool. For the next form, do we replace the current?
Yes. Go ahead and try it.
Easy peasy. Since I equals V by R from Ohm's law, we have power equals voltage times voltage by R, or V squared by R.
Good job. Make sure you remember these versions of power. And don't forget power in terms of work done and charge as well.
Register now for free.